Okay, this is absolute value part 3, and I'm going to be doing an analysis of an even more complicated example. So, first thing I'm going to do is give you the one that we're going to try to graph and then analyze. So it's y equals negative 1/2 times the absolute value of 3x plus 6 and then plus 3 at the end. Okay, so let's get started with the analysis. And we're going to start by finding out sort of step 1, the vertex. Everything kind of revolves around the vertex. Let's figure out exactly where it is. So we know that it's this guy here, 3x plus 6, wherever that equals 0. So I'm going to go ahead and solve that. So 3x plus 6 equals 0. I'm going to subtract 6 to the other side, and then divide by 3. Okay, so I have the x-coordinate. Let's go ahead and figure out what the y-coordinate is. We'll just do that on the side here. So I would have y is equal to negative 1/2 absolute value of 3 times negative 2. I think I'm going to run out of room. Plus 6. So I'll just put the plus 3 down here. Okay, so let's get out the numbers here. So we got negative 1/2. Now in here we're going to have negative 6 plus 6. So that's going to be times 0 plus 3. So that gives us a y coordinate of 3. So now we know where our vertex is. Negative 2 and a y value of 3. So that's our basically our first building block, if you will. Now I'm just going to clear out the work that I just did here, so I have room for what I would call step 2. So, oops, okay, let's just get rid of that, and let's get rid of this stuff over here. And that little bit. Okay, so step 2, so we know where the vertex is. What we want to do is see what's going on either side of the vertex. So I'm basically going to take a table of values, and I just figured out that the vertex here is at negative 2 and 3. Why don't we see what's going on at negative 1 and negative 3? So if we plug negative 1 into this thing, we're going to have negative 1/2 times 3 times negative 1 plus 6 plus 3. So this is going to be negative 1/2 absolute value. Now this is negative 3 here plus 6. So that's just going to be positive 3 plus 3. And so we're going to get negative 3/2 plus 3. So I would go ahead and do that on my calculator, and just put it into decimal form is probably the easiest. And so that's going to give you 1.5. Okay, so when we plugged in the negative 1, we got a y value of 1.5. Okay, let's make a little room here for the next one to analyze, and that is if we're going to plug in negative 3. So we're going to get negative 1/2 absolute value of 3 times negative 3 plus 6 and plus 3. And some of you probably suspect we're going to get the same y value because of the symmetry of the graph. And I think you'd be correct, but just to be on the safe side, let's have a little look. This is negative 9, and negative 9 plus 6 is negative 3. But when we absolute value that, we're still going to end up with positive 3 times negative 1/2. So we're going to get negative 3/2 plus 3, and yep, 1.5 again. So there's our table of values. The next thing we want to do is get a picture of this. Now I'm going to clear out the whole page here so I got room for my grid, and let's just paste that in. So there's the grid, and we're going to plot these points now. I won't rewrite the points. They're probably down in your notes. So we have -2 and up 3. There's our vertex. Then we have -1 is up 1.5, so it's right there. And we had -3 is up 1.5. So we've got a little bit different stuff going on here, but we can see our V shape. So we've got a line going through something like that, and we've got a line coming down here sort of about there. And of course we put the arrows on because the graph does go forever. Okay, so we've got our vertex. Let's just list the domain. Again, it's all numbers. Range, this time it's a little bit different from what we've seen before. The y values have a maximum of 3 at the vertex, and everything else is smaller than that. So I'm going to write y is less than or equal to 3. So there's our domain and range and our graph. And the only thing left to do now is a piecewise analysis. So I'm going to clear the screen, and I'm going to rewrite the original function, which was y equals -1/2, absolute value of 3x plus 6. And then we're going to do a nice little piecewise analysis. So the trick is we're looking at the left side of the vertex, so when x's are less than -2, and then we're going to be looking at on the right side when x is greater than or equal to -2. Now it might be easier to start with the right side. What happens there is that if you take a number, say, that is to the right side of -2, say -1, and you plug it into your function, okay, what's happening in particular inside the absolute values, oops, actually let's just plunk in the number there, -2, or sorry, to the right, let's try something like -1. What's happening here, okay, I'll write the rest of the function. What's happening in here is that this result, as you can see, -3 plus 6, that's going to be a positive number. So really, the idea of the absolute value symbols is redundant. Since we already have a positive number, we really don't need to be absolute valuing it. So essentially, we can just ignore the absolute value symbols and say this is exactly the same as if we just took 3x plus 6 and left it alone. Okay, and that would be true. So I'm going to just clean up the equation a little bit, make it look a little bit nicer. So we would have -3/2 x. Then -1/2 times the 6 would be -3 plus 3. And isn't that nice? They kind of cancel with each other. So the one side of our graph would be described by the line y equals -3/2 x. And that's the right side of the graph. On the left side, we have to do something about the fact that the stuff in the absolute value, let's pick a number like -3 that is in this domain less than -2. If we try something like that, okay, what should be very clear is that you got -9 here plus 6. Well, this is always going to be a negative number. And so we want to turn it positive. That's what the absolute value symbols do. So what we're going to do is we're going to ignore for the moment -1/2 times, and we want to turn this business here, this 3x plus 6, we want to turn this positive. And right now it is negative. So we do that by putting a negative sign out in front of that. Okay, because the negative turns positive. So that's turning this business here positive. And what I'm going to do is now clean up my equation. -1/2 times the negative that's out in front becomes +1/2. And then we still have the 3x plus 6 plus 3. And if I clean it up a little bit, we've got 3 halves x, and then 1/2 times the 6 is 3, plus 3, and I can probably just squeeze it in at the bottom here. This is going to simplify down to 3 halves x plus 6. So there's our piecewise analysis. We have two equations that describe the same thing as this absolute value function that we wanted to work with. And that is the end of part 3. A little bit more on absolute value with part 4.